Alright, so we're going to get ourselves kind of a combination footprint here. We have this PG1350, which fits our low profile Kale switch. And we're going to be combining that, or trying to combine that, with our Cherry MX, which we might be able to do. But we're also going to be combining it with our Cherry MX hot swap. So this is going to be a little bit something. Not sure yet. Might work, might not. So the deal is we've got this MX layout here. We have to maintain our orientation, and since we're doing a PCB only build, we don't have space for the plate. And since we don't have space for the plate, we're not really allowed to get away with much space on the entire piece. So it needs to be a tight fit. And there we go. So our tight fit is also going to try and make use of the posts, the connector posts. There we go. Might be a little tight. Loosen it up a little bit. I just don't want the switch to rotate a little bit and get unseated. That's probably good enough. So we've got 0.037. Point 0.037. That's inches. We'll change that to millimeters. 0.9398. And our opening holes here. Hole size. That's weird. That doesn't make any sense. Oh, I don't like that about the Kicad now. So our hole size is 1.72, which is less than ideal. 0.9398, and then we've got 1.27, and we'll X swap and minus. It's a third of a millimeter essentially. Yeah. Third of a millimeter is probably fine. That's what I had, and then it was 127. So 1.27 plus. I don't remember. I don't remember what I had. It was 0.98 something. We can split the difference. 0.332 divided. What? 0.33 and then 2.65. How do copies that come out? It does. Very nice. Undo. 6.5 and then 1.27. Invert. Subtract. Copy. Let's try that change again. Tighter fit. I'm pretty okay with that, I think. see what we get. This is something of a test too. Oh, I hadn't even thought about that. I should probably build this into mic layout. I'm just trying to figure out. So the issue is that this, the Kale chalk switch has a different base of these PCB mounts here. So they're actually further apart than the mount PCB. Yeah, they're further apart than the Cherry MX. So these PCB mounts. So the idea was that you take them and turn them this way, and then you can spread them out further, and that way you can mount this way or that way. And Chalk has Kale has switches that can do that, but it's less than ideal because, well, for me at least, because the Kale Chalk switches that I have have a horizontal mount rather than the. There we go. So it can only take keycaps in two directions, either right side up or upside down. Otherwise it's not going to fit. But they did come up with later ones that have a reversible post. You can rotate it 90 degrees and it'll still fit. But I don't have those. So setting this up as a combination key is kind of doable, but the overlap on this is not quite right. The other thing is, I want to maintain the orientation, and I really like the MX post positions that I have right now. Discard changes, yeah, because these post positions work out really well. They're good, very tight fit. They're a good friction fit, and I don't want to get rid of them. But the chalk switches have holes that are not quite that position. They're over by 0.5 millimeter, but the diameter is the exact same. So by doing that, I will necessarily loosen the MX switches, which means we either tighten up the the solder points so that the switch doesn't rotate slightly. And we're talking about like fractions of a degree, really, but you can still see it. So that's what's kind of weird about this. I was messing around with this earlier, and this is for the MX here, and then the chalk when mounted horizontally or 90 degree offset. So you mount it at a 90 degree, and then it'll work, and you could have these same holes but at different positions. So this should be 5.5 Y. Yeah, there it is on the Y axis, and this one is 5 point something. 5.08, right? That's for the MX. That's negative 5.5. What? How's the Y position positive 5? Oh, this one was negative. Okay. So there's some mix and matching we need to do here. There's also this lovely socket optional. No, not that one. There we go. This one, and we can combine it with one of these down here. So we can get positions for these pads and then the overall size openings for these things. But if you consider this, then you have an MX layout and then you have the socket layout, but this doesn't offer you a position for the regular Kale chalk switches unless you do that 90 degree. Unless you do it really tight, because it's like right here and right here, I think. You do it really tight on the posts, and that way these Kale switches they'll be oversized, or you can probably cut off the PCB mounts. I don't know if I want to do that, because the Kale switches are further out, which means we'll have to like split the difference, which is less than ideal. It's a point for 5.08. Yep, there it is. 5.08, 5.08, and 1.7. 1.7018, that's exactly right. So this is all to spec, but how do we overlay? How do we fit this in there? And the answer is by cheating. No. Yeah, so contact points are here and over here somewhere. Let's see if we figure that out. Let's just drop it onto this one since we've got it. Mount hole, we want the chalk. Where you is, there we go. This is going to be inverted, so we need to like do one of these, and then don't do that. Center. No, not gonna let me do that. All right, cool. Whatever. I didn't want it anyways. There we go. See, that looks about right, and you can see how we've got this weird overlap going on here. I'm not sure that's gonna come out on the PCB manufacturing side because these holes are very close together. This is just what makes me want to split the difference and then have it like be a slightly oversized hole with this and this as the outer diameter, and then center it on, you know, splitting the difference of those two holes, so that way it'll fit both. You know, if I did that, it would work. You think about that, it would have the same positions. The posts would just contact on the wall, on the outer wall. So the Kale switches would contact on the outside edge, and then there'd be a little bit of space on the inside. And the MX switches would contact on the inside edge. This is why I do this. This is why I explain what I'm doing, because it helps me to think. I need to think out loud. Now, speaking of thinking out loud, I don't have music going. Let me turn this down for me here. Alright. Does that turn it down for you as well? I'm pretty sure this is fine. I'm not sure, actually. Okay, so that means we need to split the difference here. So we need to get our center point between the two. I might actually need a Python interpreter for this. Let's see what we can do here. I don't even want that. I'm being weird now. I want that. Oh, what is it? It's a calculator. No, shoot. It's a. No. I know this command. Is it just cow? Oh, it's the calendar. That's cool. I actually didn't know about that command. Calculus, calendar, calc ticket adjust? I don't know what that is. Let's see what we got here. Calculator, PN. B, terminal basic, RPN calculator, concept. There was one that was like standard. Terminal calculator. Terminal velocity, no. Calc tool. You need a BC, that's what it is. I actually don't remember how to do this. This might be a problem. 6, 7 plus? No. 6, 7 plus? 6, 7 plus? 6, enter. Period. 7, 6 plus plus 6 equal. I don't actually remember how to use it. I was messing around with it, but that's not. We've got a calculator right here, so we're all good here. So that's what we need. So our hole diameter is exactly the same, 1.7018. So we need to split the difference between these two. I need to visualize. This is a problem. So position. Where are you? So positioning is this means we've got, let's get these to the left. First thing we need to do is split the difference to get the center. That means we've got, well, what's 5.5? This doesn't matter actually. 5.5. 5. Oh, it doesn't like that enter, that's right. So let's do this. 5.5 and then 5.08, and we'll subtract those. 42, of course. Let's get our 42.42 is our difference, which means we're going 42 in either direction. Silly thing. There. Put this in the right order. That means we're going 42 in either direction, but closest is 5.58, which means we'll take 5.08 and add those together, which gives us 5.5. That's not. How many significant digits do we have here? This is not. No, we want to split the difference. Genius. 0.42 minus, right. Now we'll take 0.42 and we'll divide that by 2. There. Now add those together. 5.29. Yes. So that's our new center point. Now our diameter. So our diameter is actually, so that makes this the center point, which means we need to find the end point, the extended end point here, which means we'll find the distance from here. Yeah. Because our distance between the two is 0.42. So we need our diameter, our distance from, or no. What's the radius then? So it's the diameter divided in half, and the diameter of this divided in half, and that'll give us the center point of the radiuses, and then the difference between the two center points is the only delta after that, which is 0.42. So we need our diameter, but the diameter is the same for both, which is 1.7018. And we'll, dummy, we're not going to divide it by 2 and then add it together. If this diameter is 1.7018, then our radius is half that, and this diameter is the same. No? It is the same, right? 718. Yeah, we got it. So 1.0718, or 1.7018 plus enter that in plus 0.42. No? Yeah, it's the difference between the two distances. There is our new diameter. This means we will make a new hole. The new hole's position will be position 0, our negative x position is going to be 5.29, and our hole size is that. B. What? Oh. But this is a mechanical hole. Why would... Does it just duplicate the number over there? That's kind of weird. Whatever. Look at that. And now if I delete this, look at that. Exactly the same. Exactly the same. Maths. Quick maths. That was actually rather slow. That is pretty cool. All right. So let's do this and then do this and delete those. No, that didn't work at all. Okay. So, what is it? Move G? Shift G? Yeah, that's right. This is... I can't believe I didn't think about this earlier. What about our center hole? Because our center hole is the same. I mean, it's just going to rub up against it, right? It's going to be the right size, right? And that might be up to the PCB manufacturer. We'll see how tight it fits. Right. So I actually need to delete those, and then I'm just going to Shift G. Yeah, I'll recreate these. Move that one down there. Delete that. Update the settings on this. Edit. There's a perceptible delay here, and it is very annoying. Negative 5.29. Position x is 0. Size of our x is... I should probably save that over here. 7. Go. I don't know if you can read this. Hey, oh yeah, I'll peek while I'm not. Well, you can't see it. Of course, genius. Capital Q. There we go. There we go. There we go. Bueno. Now update. Oops, I'm in the. I actually don't need this calculator right now. Okay, put that there. That there. Position is 0? No? 0? I forgot I did that. That's pretty cool. Position X is that one. I mean, it might work. I still like to tighten up the... Let's save this as... Save as... It's a MX chalk. .1. I don't like to delete. I don't like to delete. Yeah, we can keep our original. So this is the first one with the rotation. This is clever. Me and my cleverness. But I did actually want to tighten up these through holes though, anyways. Because the original through holes are 1.27 millimeters, which, if I'm going to show off my calculator here, X length conversion, it is that in millimeters, and we'll convert that to inches. 0.05, really? It's 0.05 and 0.49. I don't know about that. I don't know about that. It's 0.05. How much space do we have in here for 0.05? So 0.05. I don't like it. I'll take a few thousandths out of it. I think that's fair. Say 3.7 or something like that. 0.037. I still like 0.037 better. So that means 0.037 inches. Convert that to millimeters. 9398. Yeah. So let's switch that. Wow, really? Really? Not gonna lie, seems pretty significant. But so are those. Is this not the same for other switches? Surprised I have too much stuff on my desk. Extender. I do not have a switch on my desk. How do I not have a switch on my desk? I might be able to cheat with this. I kind of like this better. You know what? We're testing it out. Fine. Let's do it. Yeah. Be. That does not seem right. Is it right? Oh my goodness, it's right. This is a fantastic idea. This is never gonna work. Oh goodness. Yeah, no, this looks totally normal. Very normal. Super normal. I actually don't even know if this is accurate. No, it doesn't actually make a difference because these just have to be connected. Yeah, that's okay. To this skin, I added some letters here. The keyboard shortcuts. The only one's missing is this. This is a backslash. Make it easier to operate with the keyboard. Yeah, it's super weird. I don't know how I feel about that. Which means we're going to save it as 1.15. Let's see what happens. I should actually probably label. That's a good point. I should label these so I don't look at these later and be like, what? Back silk screen. So 1 point. What did I say? 1.5. Yeah, that's like whatever. This thickness, I want to make sure this is appropriate thickness for this, so it doesn't show up weird on the silk screen when it actually runs. But this is actually where I'm going to be putting some other stuff. So, can I copy this? Will this work? I actually don't know if this will work. I'm about to find out. Let's go back to our 1.1. No, it will not. It will not maintain the paste across. Yeah, alright, that's fine. Let's add our text. 1.11. Well, that ain't right. 1.1. Edit. Back silk screen. I think it was 0.2. Looks about right. Alright, cheers. Save. This delay is actually rather annoying. Yeah. Because it's got to be exactly right? No, wrong. It does not. It does not. Don't care. Don't care. Watch me not care. Oh, I care. Alright. This is fine. Everything's fine. Alright, so let's... Alright, just be cool. Oh dear. Alright. Let's get our... this reversible one. It's optional plate mount. Optional, yeah. Let's get our hole positions. That's a lovely little curve there. I wish you could overlay combined footprints. I do not know a way of doing that though. Socket left rectangle. Yeah. Negative 6.29, 5.08, 2.55, 5. Pad 1, rectangular, 70, surface mount. There we go. Alright, rectangle. And this is where we're going to see if things can actually fit. 7.56, 2.54, 2.55, 2.5. It's the same essentially. Angular, pad 2, and then left. Oops. Let's do it like that. .54, 4.08, size 3, circular. R. 3.81, 2.54, 3. Alright. Copy that over. Close that. Where's our boy? Getting lost already. There we go. This is not going to work. Now we need a new pad. The new pad. Pad net is 1. Some D. Rectangular, if I recall correctly. Our contact. Left angle. Sorry. All right. Net is 2. 70. It should also be on the back, I'm pretty sure. No, wait, that's not right. Wait, yeah. Never mind. Rectangular. Position. Left rectangle. What's that? Q. Copy point. We'll duplicate. Control D. That's right. Does this even look right? Actually, it looks just fine. This is the rear side. Yeah, we should be on the opposite side. Should be on the back layer. Hey, quit that. There we go. Back. Back mask. There we go. That looks better. Back paste, back mask. Much better. There should look much improved. Although it should have mask, back solder mask, back paste. That's right. Huh. Am I thinking about this right? Save that real quick. Am I missing something here? B paste, B mask. This looks right. Oh dear. Saved over it. Paste, B mask. Let me do that and then save it. And then I guess technically undo. There. We'll save as. So it's MX Chalk socket. This will be the first version. Should have called it sock. MX Chalk sock. Can't quite tell. I think this is okay. This looks about right. Alright, let's see. So that's the right triangle. We need the left socket mechanical hole. Do that. Is that the correct one? Number through mechanical, circular, ba-ba-dum, Q, boom. Wait. This isn't right. You don't have the mechanical hole size. Leave that. Bam. 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 Yeah, the hole size does not. Doesn't look right. Oh, 2.5, 3.0. Yeah. Where are we? Where are we? So save that. I guess it is. Hole size is just 3. Oh, does it not reset the value? Yeah, it didn't reset the value. And there, that looks better. So this will accept a MX, an upside down MX mount with the sockets, and a right side up Cherry MX, and ideally the KL low profile. And this hole's the same size, right? MX center hole diameter 3.9878. Chuck center hole diameter 3.42, so it was a little bit smaller. But I think I have an MX center diameter 3.9878. Yep. So it'll be a little oversized. The plan is to make up for this with the undersized holes over here. So hopefully things fit together a little bit better. I wish I could drop copper traces on this, but that's not allowed. Yeah, plus if I'm using the sockets here, I want a tight fit for the MX, not the chalk. Let's see what it does. That might cover the entire thing. See how that looks. It's getting closer and closer to Swiss cheese here. Let's see what happens. So let's see. Close out that. Yeah, let's. I want more mics anyways. You're still looking good here. One. Looking good. How do I hide that? And just hide the whole thing. I think we've earned a 1.0 release. It's been solid. This isn't gonna work. I'm just barely squeezing between the footprint of the Pro Micro here. I could probably do a couple of test footprints though. Yeah. Oh yeah. I do want to hide the pad contacts from the top if I can. Oh, but this would look so good with the chalk switches. Let's clear this up a little bit. I do not want this front mask. Yeah, that's what I'm looking for. I don't want it on the front. We could leave the front mask. I just want it on the bottom. Yeah. Let's try that out. doesn't need a front mask, I think. The zone might have to be recalculated. And this is a it's a voltage plane on the top. I don't know how I feel about that. It's an interesting idea. Yeah. I see we've got through hole contacts on this though. Also the ground contact is like the least thing I need, the thing I need to protect the least, kind of. So let's yeah, let's just get rid of the front mask. Oh, I forgot about that. That's interesting. That should probably be on the bottom anyways. That's tricky. Let's see how this looks. Should probably remove it from all these. I don't know. Let's test this out real quick. Come on. So let's change the foot. Change it to... Oh, this is gonna be annoying, isn't it? Yeah, it's gonna be annoying. Oh. That was actually rather fast. So MX is a generic. Yeah, this is what I want to test primarily, is this thing, not necessarily a socket. Although I am interested in the socket fit. The tighter holes, and then the oversized. This is a test piece, right? It's just. Is Emily playing with the lights? Right. I wanted to test that sizer, and then the reduced through holes. I still don't like that one. Let's do this. Chop 1.1. Change that one. And then this one, change your footprint to 2. Is it 1.5? I am confusion. Did I not make this? Oh, 1.15. Of course, yes. It looks so weird. How do I recalculate zones? Figure is a keyboard shortcut for it. Keys. Something about fill refill zones, bravo. So B. There we go. We got our ground contacts. And this is listed down here. I might move that up a little bit just so we know what it is. We're just testing. Although technically this might be a better fit. Change footprint. Do that one. Edit that one. Change footprint to that. Change, good. Recalculate zones, good. Change this one to the socket. Just, like I said, we're just testing. 1, 2, 3. This one 5. This one 1. Let's do that one. Good. Yeah, because we actually have room out here for this, for the socket test. So we'll test through holes. We're losing our button here. 2, 1. What does this look like on the other side? Top side is... It looks fine. Let's recalculate our zones. It's connected. We will delete that. Whoops. Is it backspace? There we go. And we'll backspace that one as well. To nope. It's an X? No. How do you switch sides? X, 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 X. I could have sworn it was X. Keys. Board. Via Control-Shift V. Place item. Increase routing options. Flip, no. Rotate, no. Find item, switch, toggle, high contrast. Switch, copper layer, page up, page down. What is X? Is this a new feature for the new version that I don't like? X. X is add new track. It's like a toggle. Common, set grid. Place item. Add vias, Control-Shift V. Track posture. Via, that's right. Line buried via. Okay, this is fine. DXF. Tune single track. Tuning, fill or refill. Am I in the wrong mode? Modern toolset. Modern toolset fallback. friendly. X, add new track. Ah! I don't know, lol. Well, that's really helpful. It's just gotta be like layer management. Sorry, it used to be that pressing X switched copper layers. Command toggle cursor. Fill zone. This is great. Tune single track. Decrease meander spacing by 1 step. Interesting. Fill areas in zone. Fill or refill zones. Select single track. Toggle highlight selected net. Okay. It's like it's copper layers. Page up and page down. That's all I can see. Well, whatever. Let's go back to tracks. Sweet tracks. I'm gonna go up here. I'm gonna go up here, 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 here. Ta-da! And one of these into there, and one of these into there. Good. I don't like that. D? Yeah, D is for drag. I like these angles. I like that angle even less. There we go, that looks better. Are you supposed to avoid this exactly? You're supposed to avoid exactly this. Avoid these 90 degrees. Because it tends to... it makes a place for the material, the solution that they use for finishing the PCB to pool a little bit. And if it pools, it throws things off. So 90 degrees are kind of a no-no. Well, this isn't even... Let's put a via there. What? V? This is just muscle memory. This is how muscle memory works. What is this? Yeah. So V is what I was looking for. Wait. I don't need that. Hotkeys. So what is V assigned to? Because that's the word. That's what I want to know. V. Add through via. It just toggles. So if I'm in the track mode and I hit V, it toggles which layer I'm looking at on top. And it makes things very easy to work with. So the via button is what does that. Which is not what I was expecting. I believe I added a via here. Actually, I did not. So that means I want to Control-Shift-V right there. Recalculate. Check the thingy. Yeah, looks good. This is our via. That'll go through the other side. This is all ground plane. I think I'm okay with that. You know what? I don't like vias. Never have. It's true. Bam. But also just for the sake of visibility, it's a little bit easier to see. I just want to know it's there. It's not. Is it purple? Not purple. It's a little misleading. I'll just do that for visual clarity, even if we've got a little bit of a funky angle here. There. Oh, that makes sense. Let's swap these. Somehow even worse. Well, that's actually broken. So you know what? Don't care. If this little finger of zone fill is okay, then it's okay. There we go. It's coming through. Through hole here. That's good. Yeah, I think this is better in every way here. We've got some test pieces. Got a socket test here. The 1.1 and 1.5. 1.15. And then standard MX Alps. Although I feel like this 1.1 is the safest. Is the most likely to work. Can I? Let's see what happens. That is not bad. Control Y, yeah. I don't know. I think we've still got fit in here. It's probably fine. I haven't even used this yet, so it's probably fine. Is that right? Recalculating. Bing bong. This looks fine. We're fine. Everything's fine. Let's do it. Oh goodness. I don't know if this was gonna take it. It's backspace. Is this backspace? It is. Like that. What is the track button? Board, draw, track, X. Better. Good. Is this it? Did we do it? Oh, one more. 1.1. X. Go calculate. It's a fine test, and it should produce a low profile mic. Plus this matters a little bit less if it's not aligned perfectly. Cool. Yeah, I still want this test here. Oh, different layers. better. Much better. Now, how do I feel about this? Ugh. So, huh. It's gonna be silly. Delete, 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 delete. Delete. Maybe I shouldn't mess with it. Maybe I shouldn't mess with it. Tweaks. There's my changes. Always save your work. Save your work. It's created this mess. Dislike. Oh, that was convenient. Yeah, I'm okay with this. Cut print. Let's take another look. Yeah, I'm very interested in how tight the fit is on this combination hole. What is this? There we go. Ah. This is all positive plane, right? Really? Oh, it is. Okay. Yeah, so positive plane sheared across here, and then up around here. I think I was worried about this transition, although it looks pretty okay. I can actually think of reasons why I would want these exposed on the top. Actually, I would just use header pins if I was. If I did want to. This is the 1.0 with the yeah, there we go. 1.15. All the ground planes are connected. I guess that looks okay. Cool. Shared across multiple ground planes. Through here, through there, across there. Very nice. I do like this circuit board. I do like this too. Oi! Oh, don't do that. Let's see how that looks. Better. Don't need that. even better. Look at that. Lots of zone coverage. This looks a little weird. Right in the middle here. Do that. Cool. Recalculate. Cool, cool, cool. This is kind of a footprint test. I shouldn't actually make this a 1.1 release. 1.0. 7. Oops. What was that? 0.07. Recalculate. Save. Cut. Print. Ah. Plot. These settings actually saved from the previous version, so I'm pretty sure we could just hit it. Global solder mask minimum width and or margin are not set to 0. Global solder mask minimum width. Yes, looks good. Still seems a little tight. nice. Made the connection. No. Did it fix it? It does. That's cool. That's a new feature. I like that better. Whoops. Tis the all-important step of just looking at it and figuring out what looks weird, figuring out what looks wrong. Interesting. It's fine. This is all fine. Cool. Alright. So we got footprints, we got combination footprints, we got sockets, we got mics. These are easy to run. We changed our front solder mask, cover up these exposed dealies. Should actually probably do the same over here. Oh, but it comes up from the bottom. Yeah, that doesn't work. Yeah. It was a good thought, though. I'm just trying to think about what happens if I need to drill these out. None of these are through hole, but the connection is, I mean, they're all through hole, but the connection is on the other side. It makes me want to plant a via, like right here. The whole other side is ground. So if it would have to be drilled out, it would be any connection from the top. Yeah, so any of these. Although, if I were to drill them out, any connection would, I would only use one of these holes because these are alternatives. Which means that I can flip to the opposite side and just make little connections. So they're redundant connections, but still good. Please allow me to make redundant connections. It is not allowing me to make redundant connections. So you're right there. No. I mean, technically there could be like reflections, I guess. Yeah, but even if I have to drill one of those out, does that work? Is this kind of cheating? I mean, we're testing, right? No, we would have to put a V on every... This is fine, this is fine. Oh, this is all coming through in the bottom. That's right. So the only thing we care about the top. That's pretty questionable. I don't know how I feel about that. They're gonna email me. What are you doing? Why have you done this? It's really only for these two. These are the only two that I expect there to be an issue with. Because the contacts are through the top. And if this goes here, and then I drill this out, then when I solder it on the bottom, it's not going to work. I drill this out, solder on the bottom, so I can make this on the back side. No? Let's think about this. Yeah, where am I? So, one scenario. Plug it in. Goes right here. I have to drill it out. I drill out this one. Connection goes through here, through the via, or through the through hole, and then contacts over here. So no problem. Alternatively, I go here, kill this via, kill that through hole, and then solder it on the back, which means it's no longer connected. Yeah, contact point has to go. Oh, that's an easy fix. Delete that. I'll backspace this out. We'll go X around here. Connect to this. Go from here. Connect to that. But it's still on the top. This seems like a bad idea. Problem is the contact point and drilling the through hole. I don't think I care about reflections for this. This is not... I think we're fine. Yeah. Alright. Get that here. Well, bam. Double, triple reflections. I don't know. I'll chop the traces if I have to. Let's make them a little bit more. Don't do that. Yeah, whatever. This is a little weird. I'll allow it. Distance? No, I'm overthinking this. Alright. This is weird. I'm not sure how I feel about this. That's the thing though, if I drill the through holes and we don't pass through the other side, there's not another contact pad for me to use. Maybe that's the point. Alright. Let's undo all this nastiness. Okay. Contact point comes through here. We're gonna make a via. We're gonna go up here. We're just gonna make a via. Oops. That's it. Just the via. That way, worst case scenario, we just pass through on that via. Yeah. So this is our bridge. If I have to drill out this through hole. So if I have to drill out this through hole, connection does not make it down to here, but still goes to here, which is why on the back side for the through hole, I'll just do, oops, recalculate. That ain't right. 3. Yeah. Then on the back side, I'll scrape it and I'll solder it. I don't know what that was. That was interesting. Yeah, I'll scrape the mask off this, and then let's take the mask off right now. Through. Oh, I can't change the. I guess it's not a pad. I'm just trying to see if I could remove the micro. Could increase this a little bit. 1.2. Let's do it. That's fine. Make it a little bit easier to solder too. Calculate. Looks good. Looks good. Looks good. Looks good. Hopefully they don't complain about non-standard VSIs. This is fine. Everything's fine. Yeah, so I'll scrape off the mask and then solder from here to here if I need to. Why does this load look weird? It doesn't. Okay. Cool. All right, I like it. Let us plot. Plot, plot, plot. Okay, let's see. What was the original? 0.1? Go 1.0, 0.1. Let me check the version number. Yep, 0.1. There's our Gerber. Now we'll create new ones for version number. Where is the version number? Did I delete it? I did. Why did I delete it? When did I delete it? Well, I can review the recording and figure out when I deleted it. How? Well, let me go cheat. That was the original. Alright. Let's put some text down. Go back silk, mirrored, justification center. There. Left. No. There we go. Looks good. Text size seems a little oversized. I'm sure it's fine. Good. Do our bug track. Totally fine. Totally fine. First try. Very good. All right. Let us do this. Plot it. Zones. Oh yeah, refill. Beautiful. Generate drill files. Pretty sure. Good, good. Let's check our files. Now that is odd. Weird. Try and see how that goes.